The stage is yours.
Okay, so hello everyone. I am a programmer and I represent Bank Gospodarstwa Krajowego, which is a Polish development bank. I'm very happy that this institution is getting more and more recognition in the circles of IT. I see people that start recognizing us. So, okay, let's connect. Today at this beautiful morning, I would like to showcase you the tool that I found fascinating. It is just a showcase, so maybe for some of you that are more familiar with it, it may not be that interesting, but for those who seek solutions which this tool provides, it might be a good presentation. So let's start. Okay, so first of all, we'll have a theoretical part in which I would like to discuss what is Hibernate Search, what problems can it solve, and so on and so on. And further down the line, we'll get our hands dirty and see some code. I won't be live coding as it is always, dangerous and prone to mistakes. And yeah, if you have any question during my presentation, just raise your hand. I'll try to answer them immediately. And if I will feel that I'm running out of time, then I just say that questions that will be answered afterwards. Okay. So what problems does Hibernate Search solve? First of all, it provides us with full-text searching capabilities that are compatible with Hibernate, probably your ORM of your choosing. It provides other benefits like analysis of the text that you index, and lets you character filter, tokenize, and normalize. I'll get later to what does it mean. Text through which you want to search, and you can also do something like advanced sorting. I'll explain that also later. So yeah, that's the example of what does it mean and how it works. So you can remove some characters, that's first. You can tokenize that so that the search is is split into words, and then normalize so that unnecessary words like the, or something like that can be removed. So, okay, default analyzer allow us to tokenize, split the input according to the word break rules of the Unicode, text algorithm, segmentation algorithm, and do exactly like what in the previous slide you can see. But you can also do much, much more with this approach. Oh, and okay, maybe I should start with how does it work? So let's assume that you have your model and you've already made some model to your SQL database, you've done entities, and now there is a requirement from a product owner or whatever to implement a full text searching feature. And in this case, Hibernate Search may be an ideal solution to you. Of course, modern databases already have something like full-text searching implemented in them, but I am quite convinced that not all features are as easy to implement as in case of Hibernate Search, which which combines benefits of SQL database and NoSQL database. So basically, we tell our ORM to take care of changes both in our SQL database and NoSQL database, and therefore we can achieve, we can have benefits from both of these solutions. So, yeah. We can work with two tools, which is Apache Lucene and Elasticsearch backend. Pretty much that's Apache Lucene under the hood, but you can use both approach. So you could use Apache Lucene when you want almost immediate changes, as it is only on one server. It's easier to use as you don't have to put up a new server with everything, and sadly it's not possible to scale up. Application indexes have to be on the server, can lead to the synchronization of indexes or indices and database. So more common solution I would suggest is Elasticsearch backend, and something that is still in development. In both cases, you can have some problems with synchronization despite the tool taking care of it as best as it can. In some cases, some problems may lead to this desynchronization of data between your SQL and NoSQL database. And what is being worked on is outbox polling coordination strategy, which we'll see later how it works. So this is, source is official documentation. And here we can see that in case of single node application and Lucene file system on local file system, we have a simple thing. We have application threads, which searches something through your NoSQL database, uses queries, full text search queries, and then retrieves ID, which is an database ID, and then retrieves an object which is mapped in your ORM. So this is how it looks with Lucene, and in case of Elasticsearch, we can have multiple application nodes, and we also have Elasticsearch cluster, probably with multiple nodes. Okay. Yeah, and the problem sometimes may be lack of synchronization. Then what is being worked on is a strategy in which in database we store information about what changes are made, and therefore we prevent data from being desynchronized. And what is important as well is that in case of Elasticsearch, changes aren't immediate, sadly. So if we make change to some data, a SQL database object, then probably in case of Elasticsearch, it will take 1 extra second. So if you have to have something updated immediately, then this may not be ideal. So what frameworks are supported? So first of all, Spring Boot, obviously, Quarkus, which is quite a wonderful framework I discovered, and Wildfly. Probably also others, but those are not supported out of the box with configuration, with easy configuration. Okay, so how can we use it? There are virtually 5 steps involved in setting up your application. First, you have create your JPA entities, obviously, and you would have this already if you have something working and then want to add full search capacity. So what you would have to do next is add some dependencies, annotate those entities for which you want to create an index in your NoSQL database, and then annotates fields you want to include your index, because sometimes you don't want to include everything or want to include only or want to merge some two fields or something different. So for example, we have full text field, which allows us to make full text search queries through this field. Then we have generic fields. Those are fields that like double, long, or others that can be converted to strings and be searchable in our NoSQL database. Then we have indexed embedded if we want to embed some object inside, because what we have to do, we have to transform SQL model, which is basically a graph in which every object is a node and every yeah. So and you have edges that are between two objects. Then we have we have to transform it into NoSQL database, which at best case is a tree with multiple roots, probably if you have multiple indices. So then we have geopoint binding. That's a very neat feature and something that I believe wouldn't be easily achievable with some solution that require only SQL database. And at last, we have to write a piece of code to take care of initial indexing. So when we write this, we declare that we want to have those annotated fields transformed, mapped into NoSQL model, and we get everything out of SQL database and update our NoSQL database. And afterwards, when application is already started, everything should be taken care of as long as we use our ORM to update database, because both of them should be updated at the same time as long as we let Hibernate do the work. So that's it. Now we can start writing queries based on, okay? Mm-hmm.
How to be with the data?
So probably in case of some events in which you have to add a field or you, okay.
It's different. You know, when you update the database,
Mm-hmm.
in
SQL.
Yeah, SQL
Okay.
database. In a single transaction, you can populate outbox, table, and then
Yeah.
workers just read data from this. It is a change data capture pattern, right? It populates data to your Elasticsearch.
Yes.
In case you just need to start from, let's say, point 0,
Mm-hmm.
fully populate your database, then how to be in this case?
So at the startup of application, or you can always do it at the runtime if you have it written into your program. So you shouldn't have data, unique data stored in your NoSQL database. So that's not a problem if if it is no longer available. And if you have to recreate it from the scratch, you can just invoke appropriate method to repopulate this NoSQL database. That may take time. That's the downside. So if for some reason NoSQL database is down and you have to repopulate everything from scratch, then it takes, depending on data, several minutes or hours. I don't know how big your SQL database might be.
Usually half a day.
Oh, yeah. So that may be a problem, but if it runs all the time and only ORM is used without any updating outside your Hibernate framework, then you should be fine and it should work.
Right. Thank you. That answers my first question. And second question about, okay, I know Lucene, the Elasticsearch supports basic search, right? This is a very useful feature.
Yes.
When, let's say, you just need to provide UI with a panel when you can choose attributes of any field, and it quickly narrows down your search result. And if I need that type of experience, can I use the Hibernate and these annotations to create a basic search?
Yes, you can. I haven't used it personally, but it's, yeah, surely you can.
Okay, very good. Yeah, thank you so much.
Okay, so let's go further. Okay, after we set everything up, there are multiple tools at our disposal. So querying, and we can have multiple types of query, exact like in SQL database, or fuzzy, where 2 or more letters can be matched differently. Yeah, we can select through range of values. So wildcard and regex support is also a nice thing to have, and we can have phrase queries allowing to match a sequence of words. So if we search like in Google 3 words, we'll just get results that are, yeah, at the end. Yeah, so you can do it similarly to the Google style. And let's go. Okay, we can also sort, and some things that could be difficult is sorting based on score. So for example, if you look up a word, I don't know, butterfly, and you have text with 3 butterflies, and other text with 1 butterfly in it, then the text with more butterflies will get first, like I believe it's here. So for example, if we query Hibernate BGK in title and description, the results should look like this. So the less things are found, then the less score it gets, and it is put down. So basically like in Google. So what else? Simple query strings. Yeah, we can use just Lucene query normally, and all its functionality. And okay, by field values, we cannot sort. So, okay. Okay, so field values are those values that cannot be used for full text search, and for example, I don't know, some status or something like this. And what is the most interesting thing is sorting by distance. So in Elasticsearch, you can have localization, and for that is usually written as longitude and latitude, yeah. And you can sort things by distance. So it's a very neat tool. If you have something like this, you can use just a few annotations and then sort results for apothecaries near you if you have an app that searches for apothecaries for some reason. Okay. And we can use projections, okay?
Yeah, just one question. While we're talking about search capabilities, so if we need to search, let's say, in 2 indexes or 3 indexes, so can we do that?
Yeah.
Find results from 3 indexes, like join in a SQL.
Okay, difficult question. I would have to. Okay, that's a difficult one. I believe yes, but wouldn't be so sure. You can have multiple indices, but then when it comes to querying, I haven't done it and I haven't read about it, so yeah. So sorry, I can't answer to your question right now, but maybe I'll try to find out quick. Yeah, so we have some other tools, for example, projections. We can just skip a query to SQL database altogether and just get index results. Sometimes it may be beneficial and quicker, that's for sure. Okay, so we will have some code right now. If you want to look it up for yourself, there's a link. I'll probably show it at the and also. Okay. So in my presentation, I'll use MySQL database, which will deploy with on Docker desktop with some Elasticsearch server and with some Kibana to see what is going on. So that's not really necessary. Okay. 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 Okay, everything is going up. Great. Okay. Also, we've just populated our database with tables and some initial values. We'll have books with some authors and reviews, and we'll try to make full-text search queries that include both description of the book and reviews. So as you can see, the database should be already up. I'll just refresh it. Okay. Yeah, so we have some books, but as you can see on Kibana, if it is up, there won't be any indices because we haven't yet started the process of matching those both databases. Discover. Yeah, no data, first unit data. So let's get to code. We have already our database and our Elasticsearch server running. Okay. So let's look what we have inside our code. So as I said, firstly, you need to have some JPA entities, for example, in this case, book, and yeah, everything. I also use Lombok, so annotations are getting out of hand here. Okay, this I'll talk about later. We have to have just two simple dependencies in our case. Yeah, we're 2 minor versions behind. Or 3. That's not a lot. Oh, outbox polling strategy. That is definitely not necessary in our case, as we won't be using it. But okay, I'll just leave it here. So there's that, and then the most important part, second most important part is tell our ORM how we would like to handle mapping SQL database to NoSQL database. So, for example, if we have this object book, we just annotate with indexed, and in this way we say create new a question. Okay. So we are just saying create an index that is called book. And that's all. And here that's not enough, sadly. We also have to say what fields we'd like to put into our database. And okay, let's start with title. And as you can see, that is quite nice feature. You can map the same field twice as different types of fields. So you can use it like as full text field, which can be searched, and a keyword field that can be sorted through.
Just one quick question. So as I see, this is a kind of model for the normalized schema. And for Outbox, you probably would like to have denormalized schema, so having everything in one document.
Mm-hmm.
And what would you suggest how to proceed with that? So if we update, let's say, objects in normalized schema, then in Outbox should go some denormalized object. Possible to do?
So once again, please. So what we would like to achieve?
So the object, well, you kind of map plain object, right, to the table.
Yeah.
So, and you have normalized schema in your database. Now a lot of such like book.
Yeah. And you would like to have a non-normalized.
Yes.
Sure.
And in Outbox, I would like, let's say, to transform the schema to have a different objects coming into Outbox and coming to the Elastic cluster. Can I do that?
Yeah, sure. You could put it in Elasticsearch cluster as multiple times the same field, and a non-normalized field you would usually have in your SQL database.
Yeah, right.
That's the master of your data.
Maybe practical case, okay.
Okay.
Book and authors, right?
Uh-huh.
So in normalized schema, I have one book in one table, author in another table, right? And I would like to have book, including authors, come into Elasticsearch.
Okay. So embedded index, right? That's
Yeah, yes. So embedded, I would say object instead of
outer.
association, let's say.
Yeah,
Say aggregation.
you can't really create associations in NoSQL database, but you can surely have it put inside your NoSQL database as embedded index. So yeah, and here we have something like this exactly.
Right.
So maybe, yeah, a little bit early question. So yeah, you can surely do that, and you don't have to put those objects as different indices. So in case of this simple application, because we don't annotate review or author with this annotation index, we won't create those indexes, and we'll just have one inside which we'll have reviews and authors, and we will be able to search through them and then retrieve non-normalized data, non-normalized reviews. That's okay. Yeah. So yeah, there's this. Yeah, full text field you understand. We can attach some analyzers, which I've talked about, some normalizers, which I've also talked about. We can and definitely should give name, especially when we insert one JPA field as multiple fields in NoSQL database. Yeah, we can say whether it is sortable or no. I believe that this is a default. So yeah, we have this, and these annotations are enough to say what we want. Those are full text field. Anything more interesting here? Yeah, there are more interesting things. For example, as I said, geolocation is very interesting, but we won't have time to get into this, and I don't have source code for that. What more? So we told Hibernate how to map one schema to another, and now we would like to populate. In case of this application, we'll populate only at startup. And it's, I believe, here. Yeah. Yeah, so just at the startup, implement application runner, we use index service and initiate indexing. And this is, yeah, this, I'll close that. This is the method that does all the work when it comes to populating for the first time NoSQL database. And that's all, basically. Also, we have here configured some named normalizers and analyzer and normalizer, and yeah, it's standards, nothing ASCII folding, so no fancy characters, lowercase, definitely, yeah. And we can attach them to this model. Yeah, we will use SpringFox to see what is going on. So, okay, I believe that's everything I have to show you right now. Okay, book service, book repository, okay. So I think we're ready to start. Okay, all entities indexed. So we are ready. There were 5 entities in our database, as you can see, and we'll see if it's true. First of all, let's refresh this and see in Kibana if it is what is really going on. We haven't enabled our security. Yes. So, yeah, for example. Okay. It shouldn't be necessary. Okay, so as you can see, we have all those fields inside book index, which we can search through. Okay, spend page, more. Yeah, that's everything. Title and title sort. So as you can see, those are different types inserted into database. We can see here whether they are searchable, whether they are aggregatable, or excluded for some reason. This is everything you could do with annotation in your JPA class. So yeah, I've already put some books, as you could see earlier. Okay, let's refresh it, or no. So we can get all books. Should be 5 of them. ID 1, yeah. ID from 1 to 5. Everything is correct. And yeah, now we can do some full text searching by using these method search phrases. Yes, let's start with code. In case of searching, we will use index search book repository. And this is how you can search through your NoSQL database. So in this case, we'll take a search phrase, which is a string. There can be multiple words, not only one, as we will see. So we'll have scope. Yeah, and here we say through which index really we would like to search. And I think you asked about searching and from multiple index. I haven't done it. I don't know. So yeah. So yeah, we give scope and we write some predicates, and in this case we want to search through description and contents of the reviews, and then we would like to sort by title, and this is why we had to create these fields and fetch me only 20 results. Yeah. Pagination, there are methods that can count. So, whether there is pagination already out of the box, I don't know. But you could make it yourself, that's for sure. Because there are methods to count those. Have I done it? Final, no. Count. No. Yeah, you could do it by yourself, but that would be quite, well, challenging. Not sure. Okay, fetch 20 results, so it looks like this. And we already returned book, so entity that is from SQL database, normalized and everything. And yeah, I think this is good example, recommended, yeah, once again. And I've highlighted, I would like to highlight here all words recommended. So it found ID1, it ends with us, and we have here recommended. Okay. Okay, never mind. So we can also, maybe you'll give me some catchphrase I could search for. Python, okay. Let's see anything about Python. Okay, there is one book, so Python Crash Course. We found it. We searched for description, so title was included, but in description it's, yeah, sure. We can probably make a mistake or no. No, we can't because we haven't, used the fuzzy search in which we could swap some letters.
Do you have some book with 2 reviews? And
Yeah, for sure, but I would have to, here. All books, let's see which one have 2 reviews. Okay, so for example, review 0. Oh, yeah, here. Reviews, 2 reviews.
try to search for those kinds of
Okay, so here I see, for example, worst book, probably. No, I don't know, I haven't read it.
could you search with those
Yeah. With title? Yeah, I would have to change code, but it's easy, so I can do it on the fly, I think. Yeah, so where is it? Okay. Service, repository, here, and let's add title. So it's that easy. I think it's just title. Okay, let's rerun. Oh, and I haven't yet showed the application IML. So yeah, we have only declared our data source. Very securely, we are using root. And we can also declare our schema management strategy and for Hibernate Search, and which kind of backend we would like to use, whether Elasticsearch or Lucene. Yeah, we tell that it's URI, and we say that this is analysis configurer, where the configuration for our application is all those normalizers, tokenizers, and so on, so on. So yes, that is all. Okay. So by the title, something characteristic, for example, ends. It ends it was okay. So it's found with every review and yeah, from SQL database. We can also, as I said, use multiple words, and in this case, the default is that it will retrieve all the results that match or ends or Python. And yeah, we have two boxes. Python crash course. It's a little bit small for you, probably. Okay. Okay, so I think that it would be all that I'd like to showcase. Are there any questions or any other things that you would like to see, as we have a couple of minutes, I believe? Okay, please.
Can you check a link to this repository because it works for me?
To repository, yeah, sure. Okay. By the way, I have to update it because some changes are only locally. Okay. I have to change it. Oh God. Have I changed the namespace? Yeah. So. Wi-Fi, yeah. I don't have my phone. Okay, so everyone who would be interested, please come to me. I'll share it with you. No problem. I just have to get my phone.
Maybe one question.
Mm-hmm.
At what moment the data comes to Elastic? I mean, imagine you have an entity, and we are updating book entity in SQL database.
Mm-hmm.
And we have all these nice annotations, indexes, and embedded indexes. And so, well, can you walk me through the flow? Okay, I start transaction, put entity to the database. Then the data comes to Elastic, and happy path scenario and negative path scenario.
Mm-hmm.
What happens with the data? What appears in Elastic? What appears in SQL database?
Happy case scenario, you update your SQL database, so that's first thing you do. Then you get to know Elasticsearch that there were some changes made, and at last you commit if you wrap everything into transaction.
So the Java orchestrates everything, and it comes synchronously, right?
Mm-hmm.
Okay.
So there is little to no chance of desynchronization, but it could happen for some reason.
What if
And
Elastic is not available?
yeah, that may be a problem. Then
What could be? What happens with the data within SQL database? What happens with the transaction?
so if you don't wait to Okay. So if you don't wait for response from Elasticsearch, then you can update only your database. If you don't wrap also, like, yeah, everything into transaction, then changes in SQL database will be made, and Elasticsearch no, and yeah, that's the synchronization right here. Or you can fail everything and every method won't work. So.
Questions? Okay, in that case, thank you very much, Bartosz.
Thank you very much.
Here's a small gift from you, for you. Once again, thank you very much for joining us.